area of a triangle. So what I'm going to do right here is I'm going to create a triangle. Okay, and on Sketchpad, if you wanted to identify the area of a triangle, any ideas on what you could do? Anybody explored enough to find? Okay, so when you look under this measurement, you see that there is an area. Okay, how might you identify that area? What if we select the points? Will that work? That gives you angles. Okay, what if we select the points and the segments? Still no? Okay. Any ideas on how we can get to the area of this figure? Okay, if you've opened this, I want you to see, can you figure out a way to calculate or measure the area of this triangle? In order to measure the area, you have to designate the interior of this shape. Okay, so is there anything that allows you to identify the interior of a shape? Okay, if you look at this command, the Control-P command, okay, if you designate the 3 points on your triangle, and then you hit either Control-P, or now it opens up, right, under the Construct tab, it allows you to fill that in. Okay, and now when you highlight it, and you click on Measure, it gives you the area of the triangle. So when I'm asking you on these to demonstrate the area, that's the steps that you'll have to do. Any questions on that? Everybody follow? So click your points. Choose Control-P. The P just represents the interior points. Okay, so you're going to fill that figure, and then you get your area. Okay. What is the area formula for a triangle? 1/2 base times height. Everybody's familiar with that? Let's confirm it with a calculation. Okay, and so in this, let's use base AC. Okay, if we use base AC, let's find what that length is. That's a length of 5.91. What represents the height of this triangle if we're using base AC? Is it distance AB? Okay. Is it distance BC? No. What you have to do in order to find the height of a triangle is you have to use its height or altitude, which is a perpendicular segment from the base that you're using to the opposite vertex. Okay, so I want you to see, can you create a perpendicular from AC that passes through the opposite vertex, in the case that I have up here, point B. Okay, how can you create that? Choose the point you want the perpendicular to go through, choose the segment that you want it to be perpendicular to, hit Construct Perpendicular. Okay. And what you need to do is you need to designate this portion of it from B to this intersection. So let's label this intersection. Okay. I'm going to label the intersection. And now when you guys did your bonus work, a lot of the problems came because you're not connecting pieces, you're not tying pieces together. So anytime these things intersect, in order to find that point and tie it to both, if you highlight both of them and hit Control-I, it'll give you all the intersection points. Now this point will always stay perpendicular right beneath point B. So even if I were to move A out here, that point's always going to stay relative. Okay, so you want to keep it relative that way. Okay, so you create this. Now, once we label this point, we can now use our Control-L to designate just that point. Highlight B and then this point, give it a segment, and then we can go back and we can hide this perpendicular. So all we see now is the altitude or height of this triangle. And we're just going to go ahead, I'm going to call this point D here. Okay, so here's my corresponding height if I use AC as my base. So let's measure that distance, and we get a length of 4.69. And if this calculation is correct, if 1/2 base times height is the area formula for a triangle, what that means is I can confirm with a calculation that if I take 1/2, so 0.5, times the base, which is CA, times the height, which is dB, I should get a value that's identical to what I see as my area, and I can confirm this. And the confirmation comes when you move it. Again, this is one of those things, for a lot of you, when you didn't tie your bonus stuff together, anytime you tried to move something, you had to realign all your pieces manually. You want to try to tie it and connect it. So here, this area, no matter where I move these points, the area is always going to stay the same. All right, let's go over this again. Okay? This time I'm going to use a different pair of base and height. In any given triangle, 1/2 base times height is consistent no matter which base or side that you use. So let's say I want to use side AB. So let's measure that side. So AB is a length of 6.77 approximately for me. In order to find the corresponding height to this, I need to construct a perpendicular through the opposite vertex. And then I can separate and find where that intersection is. So I highlight both of them, hit Control I. There's my intersection point. Okay, and I'm going to label this point E now. And I can designate my segment from E to C by highlighting those two and hitting Control L. And then I can hide that piece. So now EC for me is a perpendicular to AB. So if I measure that length, it's 5.24. What I should get is 1/2 the base of 6.77 times the height of 5.24 should also equal 17.74 for me. So let's take a look at that calculation. Is it true that 1/2 times the base times the corresponding height is equal to 17.74? Yes, and once again, wherever I happen to move these, everything stays relative, and the areas will all be the same. Hey, let's do the same thing one more time with the final base. Okay. So I want to find base BC that has a length of 5.61. Let's identify the corresponding altitude. So highlight the base and the point opposite it, construct a perpendicular through that. Find the point where the perpendicular intersects the segment using Control I. This gives me the point on my triangle that identifies my altitude. My altitude is from A to F, so if I create a line segment there and hide the remaining portion, Control H. Okay, I have my altitude AF, so let's measure that altitude as well. It's 6.7 for me. So once again, I can confirm with a calculation. Is it true that 0.5 times my base times my height is equal to the areas that I got for all the other measures? And sure enough, it confirms that. Okay, once again, no matter where I move these, that all stays the same. Now, what else do you notice as I move these pieces or these points around? What else is happening at those altitudes? Anybody notice that? Where do those altitudes intersect each other? It's all the same point. Okay, 5.6, we're going to discuss that in more detail, but it's something that's very apparent as we're looking through these. Okay, this is called a point of concurrency, a point that in which several elements intersect at the common point, and the altitudes of a triangle do have a point of concurrency, which again we'll talk about in the last section of this chapter. Okay, but this confirms the area formula for a triangle. Okay, let's talk about one more relationship for this. Okay, if I take this triangle and let's say I pass a parallel through point B. So I'm going to construct a parallel line through point B. I'm keeping AC as it is. All right, so notice my area is 38.92. What do you think would happen if I created a triangle? Let's call this point G. What if I created a triangle AGC? So I'm going to highlight those, hit Control L. And I'll move these things out of the way. So the base AC is still the same, but point G is going to lie somewhere along this parallel. What do you think the area is going to be of this new triangle? Is it going to be larger than or smaller than? Or the same? Okay, let's take a look. If we highlight these points and we construct the interior, and I'm just going to give it a different color here so we can see the difference between these two. Okay, and let's measure this. So if we go to measure the area, what do you notice about this area of triangle GAC? It's exactly the same. Would it make sense, no matter where I put G here along this parallel, what explanation can you give for why these triangles have the same areas? Keenan? Good. Okay, so if you have this obtuse triangle, so I'm going to leave this red one obtuse, and you wanted to measure the height. The height is the perpendicular segment from the base to the opposite vertex. Well, if you have an obtuse angle here, you may need to extend your base slightly. So if I were to extend this into a line and then construct my perpendicular through point G, okay, here is my height. Well, if these lines are parallel, any segment, any perpendicular connecting these two parallels is always going to be the same, right? So that goes to demonstrate that no matter where G goes, the height from point AC or base AC to point G always going to be the same for both of these triangles. This concept is called shearing. And so you can shear a triangle without changing its area. It just means sliding a point along a parallel, keeping the base the same.